Today I'd like to talk about the induction heating furnace that I've just completed. It is based on the induction heating driver by Rudolph that you can buy on eBay, known as a flyback, and they're about 55 bucks. Unfortunately their height is just too high to fit in an old DVD CD case. So I removed the CD components, DVD components, and kept the top and bottom. I had to make up several sheet metal parts, as you can see here. Had to make side mesh, rear mesh and front mesh. The reason being for mesh is that you are dealing with a lot of heat, and if you can remove the heat as much as possible, everything benefits. So on the top there's a 12 volt fan from a PC. It gets its power supply from the 12 volt pump supply through an extension lead. So that connects on in there. That cools the electronics. Then inside you will see that the board is sitting approximately in this position, and all this area is clearance. I've added a temperature gauge that runs down into the water tank, and that will measure the water temperature. As it was getting fairly heated, you need to keep an eye on the temperature. The 12 volt submersible pump is plastic, so you don't want that to melt. Above it is a voltmeter. It is connected to the terminals on the board. Now the reason for that is so it is one, it will show if on, and two, you need to make sure that there is more than 12 volts going to the driver, otherwise it will cause problems and will cause the driver to destroy itself. So now there is the hoses. This is 6mm silicone tube, and as a copper coil, one leg is shorter than the other. You will find that the silicone is fairly flexible, or in other words, fairly weak, and it will drop down across the electronic board. So I've added an additional plastic tube that runs from the outside up to the furthest most connection. That does two things. It supports the tube away from the electronic board, and also if there's a leak, it also helps drain the leak out. So that is important, because you're dealing with heat, water and electricity. A very good recipe for disaster. On the side of the case I've added some handles. They're in a position where it's actually balanced. Back further, if they're in the centre, it would be balanced. Now the reason for that is I'm going to use it for stud removal. So if you've got a motor head, you've got studs that are difficult to remove, you just have to place them over the studs, heat them up, and that will make them easier to remove. So that is that end of it. I've got a fuse for safety in case there's some electronic trouble, but one other main thing you must add is a switch. Now this switch is off when you have your power supply first switched on. You must never go under 12 volts according to the documentation, otherwise it will cause problems. So you have your actual unit switched off, you switch your variable power supply on to over 12 volts, then you switch on the unit. Then the voltmeter will show up, and that will indicate to me whether the switch is on or off and whether the internals are working. Then with the water supply, comes in with a little 12 volt submersible pump. I'm using a tank. Some people have it connected to tap water, but you must then have a drain out, and if you're using it as flexible, mobile, it's very difficult to drag the garden hose around. So I've got a submersible pump. This one is quite powerful. It will pump over 1.5 meters of water straight up the tube. So that will be sitting in the bucket of water. Now the size of the water container depends on how much heat you're using for how long. So you need to start off with a fairly large size bucket, see how you go, monitor the water temperature, and if it's not sufficient, you need to get a larger tank. Now the flatter the tank, the more water surface area that allows it to cool down. So instead of having a long narrow tank, have a wider flat tank. So that is connected into the water tank. 12 volt wall wart goes in. I made up a wire adapter. 12 volt goes in there. 12 volts comes out of there and goes into the fan. So if I lose power to the pump, I can tell that the fan's not working, then I know there's a problem. So if you can build in as many safety systems you can, the better. Once the water is heated up through the coil and is coming out at a great temperature, I'm running it through a heat exchanger. This is off an old PC. It's off a Gigabyte 6 quad model, and not all of the tubes actually connect to each other. It doesn't run around. Tube runs in, down and out. So I will test that later, see how well it works, and if it needs another fan, I can take 12 volts off and put a fan on there. Now that leads us to the main problem, the main cost is the power supply. You may have a variable power supply at home, like one of these 5 amp models that you use for your electronics. Unfortunately, they're not strong enough, not powerful enough. Even if you use like a CNC power supply, they may only put out 10 amps. If you use the variable type ones, they only put out 7 amps. You need at least around 20 amps to work, from between 12 volts and 30 volts and around 20-25 amps. So that's why I had to purchase the 30 volt 30 amp power supply. These are fairly expensive. They are $375. These are only around $50. I also do anodizing, so that allows me to do the larger surface area anodizing. So for me, I have a dual use for it, so the cost isn't so hard to swallow. But now I hear you say, alright, you've made up the heater part, where's the furnace part? Well, you purchased one of these graphite crucibles. Now this is a 30mm 6 ounce, so that means 6 ounces of gold will fit in, and if you look up the latest exchange rate, you can see how much 6 ounces of gold is. However, this is the largest size that you can purchase that fits through the coil. They come in different sizes and the next size is too big. So I would have preferred a larger size, but beggars can't be choosers. You can buy some graphite yourself and machine it up, but you'll find that the cost to purchase just raw graphite for us is more than what it is to buy something already machined. So the way you then just do that, you put, I'm going to use it for a little bit of aluminium, put it down, put it on a heat-proof block, heat up your aluminium, remove the heater, get your tongs and pour. Simple as that. Other uses are if you're going to make any little cutters out of silver steel, that type of thing, you can just put it in, heat the end off, and then quench it. If you're going to bend some bar, you can place the bar in the middle, heat it up, and the bar will be heated in the middle. So there's lots of uses to have an induction heater in your workshop, and if you have got access to good transformers, or you can afford a decent power supply, I highly recommend it. Thanks for watching.